Okay, last question for a bit, working with coat colors in mice. So just to remind you how the alleles work real fast, we have one trait, big C, little c, where big C means yes, the mouse has a color to its fur, and little c means there's no pigment in its fur, it is an albino mouse. And then we have the actual coat color, where big B produces black pigment and little b produces tan pigment. And they say here we have the mating of a tan mouse and a black mouse. Now, what you have to read into this is a colored tan mouse and this is a colored black mouse because there are two traits here that both operate on color. So if you're a tan mouse, the fact that you're colored means you have a capital C, the dominant color allele, but we don't know if you have two of it or if you're big C, little c. So for now, this parent is big C blank. And the fact that they're tan is nice. That means their color genotype is little b, little b. So that's what we know about the tan mouse. Hopefully we can fill this in later, we'll see. And then we have a colored black mouse. Similar situation. It has the color allele, so it's big C blank. And black is the same situation. We don't know if it's big B, or big B, little b, so for now all we can say is it's big B something. This is enough to guarantee that it's black because it's a dominant trait, but we don't know if it's double dominant or heterozygous. So they cross these mice, and looking at the baby mice, they say a geneticist notices that one of the offspring is albino. So if we have an albino mouse, albino is a recessive trait that you get by being little c, little c. And if you're albino, we don't have any idea what your color should have been because you aren't expressing it. I mean, we can tell from the parents that this one must have a little b that came from this parent. I'll switch colors for this. We could say this parent has two little b's, guaranteed they passed on a little b to their child, so that's got to be a little b, but we don't know what this parent transmitted. It could have been a big B. There could be a little b here, and that could have been passed on, so we don't know what to put in that space. So there's some uncertainty about the baby here, but we can work up also. We can say if this mouse has two little c's, one of these came from each of its parents, which means this parent must have had a little c, not this one. There must be a little c in this space. And the same argument for mom. This other little c must have come from mom, and this isn't a little c, so there must be a little c in that space. So sometimes you can look at a parent and say, this parent has a certain trait, it must pass on. Sometimes you can look at a kid and say, this kid has an allele that must have come from one of its parents, and you can work out, or in this case, from both parents. And you can use that to work from the bottom up in a family tree. So, genotype of the tan parent, we dealt with that. It's big C, little c, so that it's colored, and then the tan color. How would you determine the genotype of the black parent? Well, we need to see this color, and one of two things is possible. If this mouse, if we cross it with something, and it produces nothing but black, it has dozens or hundreds, or I don't know how big a mouse litter is, but if it produces tons of offspring and all of them are black, then we would have a pretty strong reason to suspect that this mouse is big B, so that all of its offspring get a big B from it, and that makes their color go black every single time. So if we observed that, the more black offspring we saw, as long as that's all that we were seeing, the more confident we would be that there's a big B in that location. Now, on the other hand, if we ever saw a tan mouse come from this, if we cross this mouse with something and we got, it would have to be colored, of course, so we could actually see the color. If we got tan, That would mean two little b's. One of them would have come from mom, and the other one would have come from the dad here. So a single tan mouse would instantly tell us that this parent is heterozygous, that it's able to pass on a little b, therefore it must have one, and then we'd know everything about its genotype. So the short answer to this is do a test cross. Cross this mouse with preferably a tan mouse because you'll see results sooner that way. And if you see nothing but black, then this mouse is big B, big B. And if you see even a single tan, that would guarantee that this mouse is big B, little b.